we can measure the momentum of any number of objects before and after they have a collision. So the blue guy, he throws a punch at the red guy, but the red guy, instead of dodging, he blocks it. If we know the mass and velocity of the blue guy, we can calculate the velocity of the red guy after the punch. Let's dive deeper and look more closely at the punch. So if this guy throws a punch, and this guy is about to block, let's say the momentum of the blue guy is like 74 kgm per second, and the momentum of this guy is 10 kgm per second. So these are the conditions before impact. Before. And then if we get a close-up on the arms colliding, this is the blue guy's fist going into the hand of the red guy. And now the momentum of this is, let's say, 34 kgm per second. And the red arm is 50 kgm per second. Here, the sum of the momentums is 84, and here the sum of the momentums is also 84. So this links back to the conservation of energy system idea. If we are in an isolated system and there is no other force acting, the total momentum of all objects before a collision equals the total momentum of all objects after a collision, provided it's an isolated system with no extra energy or forces entering. That is the conservation of momentum. So momentum of object A plus momentum of object B will be equal to so these are the conditions before. Momentum of object A plus momentum of object B. This is before. And after, it will still be equal to momentum of object A plus momentum of object B prime, to denote that this is happening after the collision. So the total momentum of the objects before the collision will be equal to the total momentum of the objects after the collision. Here's what we can say. Because the formula for momentum is mv, we can say mass of A plus velocity of object A plus mass of object B times velocity of object B is equal to mass of object A times the velocity of object A prime VB prime. So look at this question. It's telling us to determine the velocity of the red ball after the collision. So to make it easier, I'm going to use the colors MAVA plus MBVB is equal to MAVA prime plus MBVB prime. So first, let's calculate MAVA before the collision. It states 0.15 kilograms and 8 meters a second. So let's just do exactly that. 0.15 multiplied by 8, and then plus similar weight, so 0.15. And here's the thing, it's at rest. What does at rest mean? That the velocity is 0. So this will be 0, and this just no longer matters. It just doesn't matter anymore. Is 1.2, and that's equal to MAVA, which in this case, same mass, but now the velocity has changed to 2.5, and this will be plus the same weight, and then whatever the velocity of object B is. So let's do our calculations. Okay, cancel this out. And then 0.825 is equal to 0.15 VB divided by 0.15 divided by 0.15. And we know that the velocity the velocity of object B after the collision is equal to 5.5 meters per second. And let's denote that it's to the right, because objects can also move left. So for this one, it works a little bit differently. MA and VA plus MBVB remains the same. But on the other side, do you think there's still going to be two separate mass and velocities if they stick together? They actually just become one entire mass and velocity. So we can just write a big M, and let's give it a cool color. What does red and blue together create? Purple. M A B, because now they've combined, and velocity of A B. Prime, just to denote that this is coming after. 2.3, because that's the mass of the blue one, multiplied by the velocity, which is moving to the right, so 12 meters per second, plus the mass of the red one, which is 5.6, and it's moving at 8.1 meters per second to the left. So we just write a negative. So because it's moving to the left, and we've denoted that the right side moving to the right is positive, it's moving in the opposite direction, so we put a negative sign. And this is equal to MAB. To find out the mass of them together, just simply add their masses together. So 27.6 plus 45.36 negative. Okay, you combine the two together, what you will get is negative 17.76 is equal to 7.9 VAB prime, and we get that VAB prime is equal to negative 2.2481 other digits, and the question wants it in two significant figures, so all we simply do is just VAB is equal to negative 2.2 meters per second. That is our answer. And since it's negative, we know that the velocity of the combined mass is actually going left. So we can just write that here, left.